Okay, so welcome back to my YouTube tutorials. Today I'm going to take you through how to solve derivative of vector value functions. Yes, how to solve a derivative of vector value function. So I have this question here which says given that r of t equal to the exponential function of 2ti plus the natural log of tj plus t exponent 3k. A. Find the first derivative r of t and then the second derivative of r of t. Then B. Find the domain of R and determine where R is continuous. So find the domain of R and determine where R is continuous. So we have here solution. So the question is giving us R of t equal to e exponent 2ti plus the natural log ln of tj plus t exponent 3k. So the question says we should find the first derivative and the second derivative of this particular question. So we have r, the first derivative of r of t equal to, when you are trying to find the derivative of exponential function, pick the exponential function. Okay, so the derivative of the exponent times the original function, okay, which is the e exponent 2t. So here, if you find the derivative of this, you are going to get 2e exponent 2ti plus the derivative of a natural log will give you 1 over t j. Okay, yes, then plus 3t exponent 3 minus 1k. So our first derivative in this particular question is r prime of t equal to 2e exponent 2ti plus 1 over tj plus 3t exponent 2k. So this is the first derivative of this particular question. So now we have to go ahead to find the second derivative of this. So knowing our first derivative as this, we are going to base on this first derivative to get the second derivative. So here we have r prime prime of t equal to 2 multiplying with 2e exponent 2ti plus, this is in a form of quotient, so we are going to have t exponent -1. Okay, yes, if you have this derivative and you are trying to find its derivative of that is going to be t exponent 1, okay, minus 1 j. Okay, don't forget you are finding the derivative, so the negative 1 will drop down, it will turn to what? Negative t. Okay, then we have the j attached to it plus 3 multiplying with 2t exponent 2 minus 1 k. So here our second derivative of this particular question is going to be r prime prime of t equals to 4 e exponent 2t I minus 1 over t squared j plus 6 t exponent 2k. So this is the second derivative of this particular question. Okay, so we have the first derivative here and then the second derivative as this. Now, the B part, the question says find the domain of R and determine where R is continuous. Okay, determine where R is continuous. Yes, so we have to look for the domain of this particular question and check whether this function here is continuous. So the B part we have, so sorry, this is A, the A part of that. So we have the B part. Now if you consider the B, okay, considering the natural log of ln, okay, the natural log of ln, the natural log of ln. So since the natural log of ln of t is undefined, okay, is undefined, okay, then the natural log of ln is undefined, okay, if t is less than or equal to 0, okay. So the natural log of ln of t is undefined if t lies in the interval of what? Negative, okay, numbers towards 0. That is if t is less than or equal to 0. So it means that when you substitute the negative values of t into ln, you're going to get an undefined value. Okay, yes, you get an error or an infinitive value, which is going to be a huge value. We cannot determine it. That is why we are saying that ln of t is undefined in this interval. Okay, so meaning it is not continuous in this particular what? Interval. So ln of t is undefined. Okay, yes. So let's find for the other aspect. Okay, yes. So if this is undefined under ln, the meaning the interval or the range in which ln will be defined is when is when is when t is greater than 0. So ln of t is defined, okay, when t is greater than 0. So it means when you look at this interval over here, any value that is greater than 0, if you substitute it here to make this natural log function to be what defined. Okay, so whenever t is greater than 0, it will make this particular function to be defined, and that will make it to be what continuous. But if it fall in this interval where t is less than or equal to 0, it makes the function to be what undefined. Okay, so now let's consider the other part, which is the exponential natural log, and then the polynomial aspect. So e exponent 2t and t exponent 3 are continuous. Okay, throughout their domain. Are continued throughout their domain since exponential and polynomial functions. Polynomial functions are continue functions. So here the exponential function and polynomial functions are continuous function throughout the domain. Okay, yes, these two functions here are continuum function. So this is the domain. Okay, it is only these two domain that makes this particular question here to be what continues. Okay, but with exception of the length, which is the ln. Okay, this and this make the function to be a continuum function. Okay, so ln of t is undefined in the interval where the value lies between negative and 0. So if you have a value in the interval of negative to 0, it makes the ln function to be what undefined. So this is the final solution to this particular problem. So the first derivative is this, and then the second derivative is that, and then the question B part is this. Okay, so thank you for watching this video. Kindly subscribe, like, and share it, and then do not forget to click on the notification button so that whenever I update my videos, you quickly get the notification. Thank you once again. Goodbye.